All right, guys. Welcome to Amateur Radio Roundtable, a show about ham radio, amateur radio, shortwave, electronics, you name it. We'll try to cover it here. Woo! We've taken a vacation. We haven't been live for the last 2 weeks, and it's kind of felt kind of good just to not worry about trying to do a show here. But we're glad to be back, and we're going to have a little fun tonight, I think, and we've got some interesting things I think to talk about. So let's see, a couple announcements just really quick. If you're out there on and listening on world famous WBCQ International Shortwave, you're listening to us on 7490, and it is Thursday afternoon, somewhere between 5 p.m. and 7 p.m. actually. And we would like to hear from you. Send us an email to tom@w5kub.com, tom@w5kub.com. Tell us where you are. Tell us where how you're hearing the station and so forth. We'd love to hear from you. Also, hey, join our Facebook group. It's called. You can just type in W5KUB on Facebook. It'll bring you to our Facebook group. We've got about 14,000 hams and shortwave listeners in our Facebook group. We're also on just about every podcast carrier out there, from iNet Radio, Google Play, iTunes. You name it, we're on it out there. And I'd love to hear from you again. If you're out there just listening on our podcast or audio podcast, shoot me an email, tom@w5kub.com. Tell me how do you listen to it at work? Are you on the road a lot? Just give us some input, how it's going there. All right, so what I would like to do, I'd like to request you, if you would, guys, if you would, hit that subscribe button. I'm going to help you out there. I'm pointing at it right now. I'm pointing at that subscribe button or somewhere near it. Please hit the subscribe button. It helps us a whole lot to get the word out about our show, and helps YouTube to push it out to more and more people that are looking for things, shows about radio and electronics and ham radio and so forth. So please do that for us. Hit the like button and hit the subscribe button and hit the notify button. We're going to try to start coming on in between weekly shows with special little projects and things we're working on. And if you have the subscribe button selected there, you'll be notified when something new comes on. Hopefully you'll get a lot more information about some of the things that maybe you want to see. All right, we've been off 2 weeks. I almost forgot what to do here. Wow. Anyway,
yeah, you don't even know your name, do you?
I don't even know my name. I do look different, guys. I want to make another announcement, guys. I'm not wearing glasses anymore. I wore glasses for 35 years, and I had eye surgery back in October, and I can see a flea on a dog 500 yards away now, guys. I don't need glasses for anything. Wow.
That's cool.
I thought my monitors were going bad. They were getting so dingy and dull looking. I was going to buy some new monitors, man. Now I don't need to. They're bright and sharp and crisp and everything. But hey, if you got cataracts and you're thinking about it, man, don't think twice, man. Contact me. Let me tell you how easy it is. You won't even know they did anything. All right, that's my public service medical announcement, I guess, for this year. All right, so let's do this. Hey, I want to say hello to Tim, WB8HRO. He's in here. He's one of our long members that that follow us a lot, and he's here just about all the time. And reading, yes, I used to use a magnifying glass to look at small stuff. I don't need a magnifying glass anymore. Who was that I asked? VA3HF. No glasses needed. I did pay for the upgraded lens, where it gives me the bionic, the far, the medium, the local.
Yeah,
and
does
all
it
that.
make that little $6 million man sound when you focus?
I think, kind of like that,
Should have had him do your knees too. There you go.
Yeah. Kind of like kind of like Hambot there. Oh man, I'm so happy. Whew, okay, where was I? Okay, Glenn. Hey, Glenn. Man, hey, the weather's starting to change here. Hey, before I get into go around and saying hello, everybody, I want to make a news announcement here. It's not really ham radio, but something has happened today. Maybe some of you are following it. Ecuador's got a really problem down in Ecuador today. Glenn, have you seen anything?
No, I haven't.
Let me tell you what's happened down here. What's happened? It's all over the news. It's all over Twitter. The cartels, the president down here, he activated the army because I think one of the cartel head guys escaped or something. Anyway, the cartels are executing people down here. They went in on a live news television cast. They took hostages of the news people. They've gone into all the colleges down here and kidnapped like 500 students. They are executing people. They're burning people alive. The police have been given immunity to shoot these guys.
Wow.
I mean, that was given to them today. They're executing hostages. Martial law has been declared in Ecuador. Guys, it's bad down here. I don't know if anybody in the chat room has seen this, but it's like total war down here. Believe me, total war.
Wow.
And boy, I'm glad I'm not traveling anymore. You know, all my job for 35 years was to be all over South America, Europe, and Asia. And you know, I went to a few kind of places that just weren't great. I tell you, Colombia wasn't great. Ecuador, Venezuela wasn't great. But now, man, Ecuador, whew, yeah,
that does not sound good.
Just be glad you're not there, man. It's probably going to get a lot worse, man. A lot worse. Okay.
No wonder there's a big rush of people trying to come here.
What was that?
No wonder there are so many people walking all the way to North America to try to come here.
Yeah. Well, there's 8 billion people. Isn't there 8 billion in the world? Something like that?
More than 8 now.
Well, you know, maybe 8 billion people want to come to the United States. You know, we may have to put up 15 or 20, you know, guests in each one of our houses, but you know, we got to get that under control. Okay, that's enough of that. All right, hey, Glenn, come in here, Glenn. Tell me what you're doing, man. It's been Christmas time. We haven't talked in 2 weeks. What are you doing?
What am I doing?
Yep.
Oh man, I've been doing all sorts of things. I was racing the weather to get the repairs done on my house, and I just did. You know, everything finished outside other than some minor things, but now I'm focusing inside. But in the meantime, had some interesting news. Talked to both of my publishers, ARRL and Elector over in Europe, and they are both going to be starting to edit the 2 new books, you know, any day now, which means that odds are that they will both be available in time for Dayton. And looking forward to that. I'm also going to be meeting with ARRL in the Orlando Hamcation here in a month, and we're going to discuss a couple new books that have been on the drawing board, I guess the best thing you can say, for the last couple months. And no, Mark, I did not get my cobweb fixed, unfortunately. I'm hoping for a couple good weather days, and that's next up on the agenda.
That ain't gonna happen. Not in the next few weeks, is it?
I bet I'm going to get it done before spring.
Okay.
But anyway, I just got this notice on the website the other day. I will be doing a brand new Arduino forum at the Orlando Hamcation. It's Friday, 2:15 p.m. over in CS3. That's the outbuildings they have for their forums. And hopefully that'll be a fun event. Like I say, it's an all-new Arduino forum. And hopefully I can get it recorded and get a copy here. Yeah. So that we can play it here. So I mean, it's been a busy time for me, even though you guys were off playing Christmas and stuff. I've been busy. I've been doing some other things I'm not free to talk about just yet, but I am experimenting with some new sensors. They are actually proximity motion sensors, but they're radar microwave based, 3.8 gig radar. And they look for it's basically Doppler radar at 3.8 gig.
That's
And so
cool.
I'm playing with that stuff right now, and I'm thinking there's some really cool applications coming out of that.
All right. Well, listen, hey, since you mentioned Orlando, um, that reminds me, let me make a quick announcement about Orlando. I talked to Katie this week. Uh, Katie is doing much better after her surgery. She still, has some medical issues. And she's got full-time work now, and she's trying to go. She's signed up for a master's course that's going to take a lot of her time. Now, so here's the deal: she's not going to be with us for a while. She is going to Orlando, so if you guys are going down to Orlando, you'll see Katie down there.
Oh, cool.
And she's going to be our reporter, and Katie's going to come back from Orlando and is going to give us a report here on the show. So, well, we will see Katie next month here. So everybody, we're just not letting her go. She's kind of on leave right now, but I'm not going to let her go. She'll be back full time one of these days.
Well, you know this is not a good situation.
Why is that?
You're going to have me and Katie
Oh,
in the same place at the same time.
well,
Do you remember the last time we were in the same place at the same time?
mate, was I there? Yeah, I was there. I think I was there.
We went so far off the rails, it wasn't funny.
Yeah, yeah.
That was at Dayton, I
Freeze.
believe. We took over the show for about a half hour.
Yeah, man. Okay. All right.
Yeah, I'll be sure to track her down there.
Hey, let's
at,
say hello.
Orlando.
Let's say hello real quick to Brett there. Brett, you looking nice and shiny and sparkly. Come on in here.
Oh yeah, well, Lynn, I'm in Laramie, Wyoming, and it's looking nice and shiny and sparkly here. We are getting blizzard conditions with 80-mile-per-hour gusts, and I was out in them. I was fixing microwave equipment this afternoon, and just all bundled up and trying to stay warm as I went out to the shack to do that. And
Mm.
we mostly got it done. Apparently, animals were out there gnawing on our cables, and we're working on fixing that. But it's warm. I'm back in the warm, cozy house right now. So for the moment it's bearable.
Well, you need to check the dishes out to make sure the squirrels haven't filled it up with acorns. Have you seen that video?
I have seen that video. That's very funny. So far,
Yeah.
we have had that happen. We have found other strange things in our dishes, but so far not acorns.
Yeah, if you guys in the chat room hadn't seen that video, the microwave quit working. They pulled what is it, the radon cover, whatever you call it. They pulled the cover off, and about 18 tons of acorns came pouring out of there. The squirrels had stored so many acorns in there that it shut it down, I guess. Well, hey, sound like you're having fun up here in the weather. You make a snowman and all that kind of stuff, right?
Oh yeah, and well, as for acorns, we don't tend to have trouble with squirrels hiding acorns in our antennas. We have had them gnaw our cables apart,
Yeah,
and
yeah.
we've had birds gnaw our cables apart. The cables have this stuff inside them that's called floodant, and that's meant to repel water. Well, the cheapest substance they can use to make that is vegetable oil or vegetable grease, and well, the animals like that.
Oh boy.
So we have to be careful about that and try to protect our cables. I'm going to be putting some conduit in to protect ours.
All right. Well, we'll hear more about that later. And let's jump right down to Jim here. Jim, we're so glad you're with us tonight. I wasn't sure if you'll be with us tonight. Hey, Jim, give us a 1 minute or a minute and a half recap on your condition right now. I know you started your chemo up this week, and we wasn't sure you'd make it this week, but I know ham radio was your life, and maybe ham radio makes you feel better.
Um, yeah, we started chemo on Wednesday last week. So the schedule is Wednesday, Thursday, Friday, and then 3 weeks off, and then Wednesday, Thursday, Friday again, and then 3 weeks off. And that may run until June. And the problem with the chemo is it really kills off the red and white blood cells. So my body's supposed to regenerate new, fresh blood cells. As a result, my hemoglobin is very, very low, and so is my red count. So in just walking and talking, I can run out of air. And I've taken some meds that cause me to spontaneously fall asleep. So
Oh,
Tom, if you're talking and I go, it's not you, it's me.
okay, okay. Well, thanks for that warning because
That's right.
listen, one night Glenn fell asleep on the show, and
I was just gonna say.
Glenn fell asleep on the show, and we didn't know whether to call 911. I don't know if he had a heart attack. We
I,
didn't know what
You'll
I
be in
happened.
know.
good company, Jim. So yeah.
I was with a group and I fell asleep and I just was head down and they didn't know what to do.
Yeah.
Yeah.
Yep. Yeah. So one of them called my wife on the phone. They found her phone. This is a guy in the Middle East. Called my wife on the phone. Go check Jim.
Yeah. You're in good company.
Yeah,
So if it
yeah.
happens, you're
Yeah.
okay.
All
Yeah.
right.
But what I need is something attached to my ankle. Maybe that gives me a little minor shock. You
Yeah.
could
Oh,
remote control press.
we can arrange that.
Hey, you know, I used to have some dog collars that would shock the dog, to train them, And if they went to, you bury a wire in the ground and that
I
becomes
think,
actually an aerial,
yeah.
an antenna, and they won't cross it. They learn not to cross it. If I could find it, Jim, I'll send it down to you. I'll figure out some way to remote control that thing.
Well, I was just going to say the ESP32 supports Wi-Fi, so we can do this remotely.
All right. Yeah.
Yeah.
All right. Well, hey, Jim, we are so glad you're back with us tonight.
Thanks.
I'm glad you're feeling good enough to be with us tonight. We're going to see you whenever you feel like it. So, you're not obligated
Yeah, I
to
may
do
not
it.
be here for
Yeah.
the whole time, but I'll do the best I can.
Yeah. Well, look, hey, you had something interesting you're working on. You're working on a little tripod antenna or something, aren't you?
Yeah, I'm working on three things. One is a YouTube video about. I've uploaded it, but I'm gonna put it off. This is a soldering iron that delivers solder to the tip,
Oh, yeah, yeah.
uh, and the price, including shipping, $7.88
Oh,
from
Yeah.
San Diego area.
You can't beat that.
less hand to solder.
Pardon?
So you need one less hand to solder.
Yeah.
Yeah, the
One
solder
lesson.
that comes with it is not usable,
Oh,
unfortunately.
really? Really?
Yeah, it's not rosin core.
It's probably
It's just solder
maybe
wire.
oh, is it? I thought maybe it's acid core for soldering pipes or something. Yeah.
It could be. I don't think
Yeah,
they,
yeah.
yeah.
Okay. Well, look.
And
Yeah.
retested the amplifier using a new sensor, which will be the next video to be finished, I hope tomorrow. And there's my sensor. And the idea behind it is to sample, I've got screwed on, to sample RF going into the dummy load and then send it to a tiny SA
Mm-hmm.
and look at the second and third harmonics.
Mm-hmm.
And with the help of some other guys, I found out that the second harmonic needs to be down 43 dB. And the core I was using was not the right core. It got hot in a pistol, so changed
Oh,
the
yeah.
core, rebuilt the box, and that amp is now down 46 dB. So
That's good.
I'm in good shape.
Well, that's great.
And the other thing that I just uploaded is a video about this. And if I don't hit the microphone, this is a tripod that would be used to mount lights.
Yeah.
What? Oh, knew I was going to do that. What makes it interesting is, shall I continue with that?
Yeah.
By the
Let's
way,
go
or do
ahead.
you
Let's
want
go ahead and let's go ahead and talk about this.
me to? Okay. But what I wanted to do, and what I did do, was to turn it into an antenna. The tripod is 8.5 feet tall, so it was like perfect for 10 meters. I put a quick disconnect on it. It's got a 1/4 20 thread up here.
Mhm.
I used an adapter that I made to go from 1/4 20 to 3/8 24. And I put the bottom half of a quick disconnect so I can disconnect the whip easily. For those who live in an HOA or doing POTA, in theory, you could set this up, full extended beyond 10 meters, add a whip, and be on 20.
Okay.
The other thing was how to feed it. And I puzzled over that for about a week. And what I ended up doing was using a mobile mount
Mhm.
like this one. And it's the kind of mobile mount that you've probably seen. And instead of the whip being attached here, I drilled a hole into the tripod through this metal bracket with a 3/824 thread. And the other side of that is the coax connector.
Mm-hmm.
And then those screws are 1/4 20 screws, and they held the radials as I tested it. So I think what I will do if I were going to use this as an antenna that would be up and down, put up and taken down, I would use either power poles or these connectors that are sold at Home Depot that can be used to quickly disconnect wires.
Yeah.
And that way you could pull the radials, take the whip off, and carry it in. It was really good on 10, pretty good on 15. 20, it gets a bit weird because of the impedance, and I'll probably just let that go as it is. SWR wasn't bad. Anyway, it works, and as you might expect,
Well,
it's
cool.
all metal. The whole device is metal.
So you put what, like a whip? Does it have a coil on it, or just a whip?
No, I use just a whip.
Okay.
So a CB whip, for example, would probably work great to get you on 20 meters, because then you'd be at about 16.5 feet.
Right.
If you had a 3-foot whip, as I do, you could put a 3-foot whip on it, and that'd get you on 15.
Yeah. Okay. And just
no
lay
whip
a
gets you on 10.
lay a couple radials out.
I did. I laid out 4 radials for each band, fanned them out as best I could. Use the antenna analyzer, shot some pictures of the values that I was getting, and it was pretty good. And I listened with it compared to my 20-meter Yagi, and it wasn't as good as the Yagi, but shoot, wasn't bad.
Well, that's a pretty quick antenna to put up. Go out to POTA
It is.
and grab
There are
it.
lots of things. There are lots of things that we can use outside as antennas if you live in an HOA. It could be a metal table with an awning in it, and you feed that thing, or any number of things. The tripod's a great answer. This one is really good. Tripod was $28. Connector and the other stuff,
Yeah.
probably 15 to 20. And you got an antenna.
And you don't have to use a tuner with that if you use the right length whip that goes on it.
Yeah, and I prefer to have the antenna be
resonant
if I can get there. I mean, honest resonant if I can.
Well, it's okay, to use the internal tuner to kind of fine tune it a little bit there.
Yeah.
Yeah.
So I got it pretty close, and it transmitted with it. It worked great.
Well, that's pretty cool. You have to give us some reports. All the DX contacts that you make with it there, would need to hear from you.
Okay, will do.
All right. Well, that's cool. And you got a video, and you're going to put that out on YouTube?
This one's in process.
Okay.
I uploaded one tonight, and I'll have 2 more uploaded in the next couple of days. So the one uploaded tonight was a soldering iron. Next one's going to be tests on the amplifier, where I got it down to 45 dB, and why the first test I did wasn't accurate. The wrong kind of core material.
Yeah. All right. Well, hey, everybody, if you will, man, go to Jim's channel. Just type in W6LG, and you'll find him there on YouTube. And hey, subscribe to him, help him out. All the subscriptions help him. And take a look at all the videos. He's putting a bunch of them out there, and this will be one of them. And I'm looking forward to seeing it, Jim.
Thanks.
All right. Let's see. What else we got going here tonight? Oh, hey, guys, I'm going to talk in a little while. I'm going to talk about tuning a duplexer with the antenna with a spectrum analyzer. We're going to do a little of that in just a little while. I thought there might be some announcements. Let's see. Oh, hey guys, I'm still looking for. I can't believe nobody has found me a All-American 5 radio. There are only 400 million of these things. Only 400 million of these things out there. And somebody's got one in a junk box somewhere in their closet. Look and see if you got one. It's just the 5 tube. It's the little 5 tube. You can see them right there, the little miniature tubes, 35W4, 50C5. I don't want it with FM, just the old AM radio. That's it there. Comes in 100 different looks. Somebody find me one, send it to me, and I'm going to convert it to be a AM broadcast transmitter without adding any parts to it.
What?
It's going to be, it's an AM broadcast transmitter. You just turn that dial and find you a clear spot, and you can even talk into the speaker, and that becomes your microphone. I will turn that into an AM broadcast transmitter and show you how it's done without any additional parts. Actually, we need one capacitor, but I think we can steal it out of the radio somewhere where it doesn't need it. But I'll show you how to do that. I'll even send it back to you and give it to your kids, give it to your neighborhood kids in the neighborhood, and let the FCC come get them. You know.
Tom, are you going to Jackson, the Jackson Ham Fest?
You know, I don't know. When is that?
That's going to be February 2nd, I believe.
Gee.
Let's see. I got it right here. Yes, Friday, February 2nd, and the 3rd in Jackson, Mississippi at the new Trademark. I was going to say, if you're not going to go, I will look for you there, and in Orlando the following week. I will scour the flea markets, and if they've got one, I'll get you one.
Well, and if somebody's got a like a Goodwill, something like that, a lot of times people donate that stuff. You can pick one up for $3 or $4, you know. All right, well, very good. All right, what else was I going to talk about? Hey, just real quick, guys, before we get into the duplexers, let me tell you why we're going to tune a duplexer tonight. As I mentioned in one of the other shows, I've got friends that wanted to get on GMRS. Now, there's a lot of hams getting on GMRS today. So I never got on it. You know, I've been a ham for 60 years, never got on it. But I've actually ordered some GMRS radios here. And the problem is the range. It's UHF, 462 megahertz, 467 megahertz, kind of just like ham radio. And you know how ham radio is. Your ham radio, your handy talkie is going to talk about a mile or less. If you can go through a repeater, it might talk, 10, 15 miles. Well, there is no repeater in my town here. So I've decided to build a GMRS repeater for the town, or, anybody who wants to use it, particularly my friends. So I've got some GMRS radios here that I've bought. I'll be working on that. Oh, I just ordered me a GMRS antenna. Look at this, guys. Let me see if I can show it to you. An antenna's an antenna, Antenna, but neat deal. It actually unscrews here. It unscrews here in the center. And it's got some nice brass, looks like nice brass coupling here where it comes apart. I did check the antenna with some equipment. So, the antenna, it's got a nice brass connection there. It's got O-ring to waterproof it and so forth. So,
is that a collinear?
I'm not sure what it is. It's supposed to be like 5 dB, 5 dB, 5 dB gain. So, I'm thinking it's probably collinear. So, I don't have a tower here, guys. And what I'm going to do, but you guys that know me and Glenn, I've got 100-foot trees here. All the leaves are off now. And right outside my shack here, I've got a limb picked out up there at 60 feet in the air. Nice, strong limb. So we're going to take a drone and go over that limb here in a few weeks and drop a fishing line over. I'm going to pull a rope over it. And we're going to pull this antenna up to 60 feet and leave it out there in the tree. Now, there will be leaves in the summer, but hey, it is what it is. But it'll probably work a lot better up there than it would down here at 20 feet. So we're going to put it up there. It's going to probably have a 100-foot run of feed line. I've got some half-inch heliacs that's being donated to the project. So we'll have low-loss cable going up there to it. I've got a Motorola Duplexer. This is what the Motorola Duplexer looks like. It's it's the T1500. Yeah, this is the T1500 1507 UHF duplexer, and this particular one does cover 450 to 470, and of course we're at 462 here. So we're going to be I'm going to show you. We're going to do some tuning on this with the Regal Spectrum Analyzer here in a little while. So I'm working on building a repeater up, and to get it on, and we're going to see how it does. It may be just a total bust. It may not work, but it's got to work better than nothing around here. And I haven't really followed GMRS. They're doing all kinds of stuff on here. They got all kinds of internet interconnects to it. They're linking GMRS repeaters everywhere. It's just about like ham radio. The only problem is, it's not a problem. You don't have to take the test, and the price has now been reduced from $70 to $35. So for $35, you get a license for 10 years, and with that license, your entire family can use it. Grandfather, grandmother, wife, sons, daughters, everybody can use it. That one license. I went ahead and applied for. I have me a GMRS license now. I don't know who I am. I'm something like WZRW559, I think, something like that. Anyway, it's going to be fun playing with it. I've built and owned repeaters since the 1970s, and they worked very nicely, had great range, but we had some great antenna sites. I had a VHF antenna up on top of the water towers over in my city where it was, and that was 150 feet to the top of the water tank. And then I had a UHF repeater on at the county courthouse, and it was on a tower, a 200-foot freestanding tower. So we had, some pretty good systems, had them for a long time. But when I moved over here, I kind of gave them up, got rid of them, and there are no tall buildings in my little town out here. So, we're going to see how this works at 60 feet.
Well, actually, Tom, you might want to get with some of the Olive Branch guys. They actually ran a survey this week to find out who all had a GMRS license, and there was a significant number. And one of the guys is building a repeater.
Oh, is he? Well, that's cool.
Yeah, I can forward that information.
Yeah, hey, send me his information, because he may have touched base here. Now there is no coordination for the repeaters or anything like that on GMRS. There's only 5 channels, and GMRS is channelized. It's like 28 channels or something.
Do you need a license for those repeaters?
Yes. Well, you use your license. You use your same license.
Oh, okay.
Anybody can put a GMRS repeater on. You have to use your license. You do have to identify every 10 minutes on GMRS. There is a place. There's internet pages where you can actually look at a city, see where the GMRS repeaters are. There are none here. There's a couple in Memphis, but they're not reachable from here. Real quick, he's found a link for 5 untested All-American 5 radios on eBay for $29. For 5 untested. I think I'd rather take my chance with the tested one.
I'll see what I can find.
But out of 5 of them, I could probably get them going. I mean, hey guys, man, I don't have tubes anymore. I used to have thousands of tubes.
Yeah, I know.
We don't have them anymore, man.
Yeah.
So anyway, hey, back to GMRS. So that's what I'm doing. Hopefully, the weather's gonna get bad here next week, so probably a few weeks. I'm building up a little COR carrier operated relay circuit right now that will function between the receiver and the transmitter. Also, when the receiver squelch breaks, it keys the transmitter. Also, it turns the fan on. We're gonna have to put some a lot of cooling on the heat sinks, because they're really not made for continuous service. But I think it's worth a try. So that's kind of we're gonna Yeah.
Oh, just had a couple of questions. Are you going to put a tone on your repeater, maybe to keep the noise down?
Tone? Well,
are they required to identify either using Morse code or something else? I know certain ham repeaters are.
Yeah, you can use the standard tones. I was not going to put a tone on at first, but you make a good point. I guess if there's noise, like and the squelch starts breaking, it'll be keying it up. Whereas if I have a tone on, it probably would fix that problem. So yeah, I could put a tone on. I was just going to leave it open at first, but you know the new radios now is all software programmed right into the main menu. You can put any tone on there you want. You know, whether it's the tone coming in or tone going out. You know, yeah, and the repeater ID can be CW, even though it's GMRS. It can be CW, and I've got several commercial repeater IDs. Here's one right here. This is one by Raycom, and you know, I've got it programmed already for the call letters. I'll put that in there. Got the duplexer here. Got the antenna. You know, making some progress here. So we'll keep you guys posted on that. I'm thinking about, that's a CW ID. I'm thinking about maybe putting a voice ID on it. It's not required. I mean, just as long as you ID, you can ID with CW. But
Funny you should mention that, Tom.
yeah,
One of the things that I have been experimenting with is there is an MP3 module for the Arduino now. So you can record your own, and it's like a $10 module. So we could add a voice ID using the Arduino with that thing.
well, you know, I found something probably simpler instead of having to program my Arduino. On eBay, there's so much of stuff out there.
Oh yeah.
There's you know, voice IDs. I found some that will record and play back 10 seconds.
Yeah.
And they got a little mic mounted on it. So you press this button, you say this is you know, GMRS repeater 1, 2, 3, 4, 5, and let off. And then it's got just a contact. You can trigger it. You know, it plays.
Exactly.
So you know, I think I ordered 2 of them to play with, probably under $10. So yeah, I'm gonna do something like that. I think instead of this CW idea is pretty big.
Yeah.
So that's
I mean,
kind
yeah,
of
I mean, it's old school there. I mean,
you know,
come
and
on.
the thing about it, most of the people in GMRS probably got, if they hear the CW, they won't know what it is anyway. So
Yeah.
you know, at least with a voice ID on there, maybe people will know, you know, who, you know, what the license of the repeater is, you know.
Yeah.
All right. So we're going to do that, and I'm going to jump into, in just a second here, I'm going to jump into and show you guys. I'm going to get to play with my Regal DSA 815 spectrum analyzer. I've got a couple different spectrum analyzers here, but we're going to play with this one and show you how we tune these 4 cavities that's in this duplexer right here, and how to tune the pass and how to tune the notch and so forth. This is the Regal. This is the Regal DSA 815 that we'll be using to do this. So
It looks like a good one.
What was that?
Looks like a nice.
Yeah, it's pretty nice. It only goes up to 1 gig, but it's you know, it's very nice. Let's see, a couple of things just real quick. So tonight I want to talk a little about. Let me see what I got coming up here. Hey, the difference between a diplexer and a duplexer. Maybe some new people, some young hands may not know the difference. There is a difference between diplexer and duplexer. You know, a diplexer is something that you use like on your VHF, UHF handy talkie or mobile rig, maybe to go to one antenna. And what it does, it allows that UHF frequency go both ways. You know, receive and transmit can pass through that one side. And the thing with a duplexer, it's kind of a one-way cop. The duplexer, it basically only lets the signal through one direction and out the other direction. And just to simplify that, I think I've got a little thing here to show you. So on a duplexer, which you use, you know, on your repeater systems, this is kind of how a duplexer works. So the transmitter, you can see here, it goes up and out the antenna. Nothing goes backwards. Only that direction that it travels. And on the receive side, you can see it comes from the antenna down to the receiver. The diplexer, of course, the diplexer is basically bandpass filters for different bands, like your UHF and VHF, where you can put them, on. I guess you could do the same. Yeah, they do the same with on HF, I think, but they got to be some really tight filters, I think, to do that. So yeah, Duplexer allows you to use one feed line, one antenna. You could use two antennas, but the problem with two antennas is to get the dB separation you need for a repeater. You need about 100 dB of separation. And
100 dB?
Yeah, you need about 100 dB to keep the receiver
Holy
from desensing.
mackerel.
With the duplexers here, we can achieve right at 100 dB pretty easy. With two antennas, and back in the early days when we first started with repeaters, we tried the two antennas. And the thing about that was, you put one up high and aim it up. You put one down lower and you aim it down. And of course, they've got little ground planes on it, and it gives you a little isolation. But even at 40 feet between them, it's going to cause desensing. So I think the studies that were done back then, separate antennas needed to be several hundred feet, if not more, apart to get the separation you needed to run two antennas. So I'm lucky enough to have a duplexer here. I gave away a duplexer here a couple years ago and a UHF repeater to a local club here, but I did find one in the attic. This is what a typical duplexer looks like. There are cans. This may be 6 meters. I don't think it's 10 meters. It's probably 6 meters. It's possible it could be 2 meters. I don't know. Our 2-meter repeater had cans like this, and you can see inside the can. Basically, it's just a can, and it's got a rod that slides up and down to adjust the resonant frequency in there, and you got a couple little pickups you adjust, and that causes your band pass there. You can get, like, for instance, GMRS has a lot of duplexers out there you can get. You can get a mobile duplexer. I'm not sure why, but they're small. They're very, of course, they're not going to be near as good as that Motorola duplexer I've got. The small size creates some issues, and probably the quality is not as good as this duplexer here. So you can see on this duplexer here, we've got a couple adjustments. We've got the knobs there, adjust the passband, and we've got you see two little screws with nuts on them popping up in the center of each of the cavities. That is a little pickup that you can slide. And I'll show you that in a minute. And that adjusts the notch in there. So we'll be using the Regal spectrum analyzer to show you that. Let's see what else we got here. The bottom picture here is the configuration of our 4 cavities. You can use 2. You're not going to get enough separation though with it. We expect to get close to 100 dB isolation with the 4 cavities here. And I want you to look at the very center, the center between those 4 bottom duplexers, and look at that T connector. You see how that T is mounted. You have to look close, but let me see. I can maybe make it bigger here. Let's see. You see how that T is right there. You would think, well, why don't each side go in each side of the T and you come out with the antenna from the center? Well, I don't know, but according to the manual, this is the way that the duplexers should be hooked up here, and the antenna hooks to the end of that T connector. Now, you will see a picture of the T connector incorrectly, and a lot of people do put it incorrectly, and I'm not sure if it causes any major issues or not. Now, another thing, these cables are specific lengths for the frequency bands that this repeater duplexer will work with. So besides the cavity, you've got specific lengths of these cables for specific bands. Here's the specs we're going to see on the duplexer, and we're going to look at in a minute. I've got the one there on the very far right. That's the T1507 right there. You can see it's a 5 meg split. A couple of these other duplexers go down to 2 megs or 3 meg split if you want to. Receiver isolation, it's showing, it says, I think it's minimum. Let's see. I think that's minimum. They're saying we'd get 55 dB there, and on a transmit 55 dB. We're going to get more than that. Let's see. Receiver insertion loss, about 2 dB insertion loss. Now, if you look at the other duplexers, they're in the center. You can see they've got like 1.4 dB, 1.6 dB loss, and they've got a whole lot more suppression. But I think that's because they are built for a very much narrower bandwidth, like 406 to 430. There's another one 430 to 470, and then 470 to 512. If you look at the T1507 that we're going to be playing with, it covers 406 to 512 with just a few modifications to it. So that's kind of what we're going to talk about there in just a few minutes. Before I do that, guys, let me go back to you there around the room here. You got any new things coming up, or any comments you'd like to make?
What's the queue on something like this? It's got to be incredibly high, I would guess.
Yeah,
I mean,
I don't know, but these things are very, very well built with finger stock, and the way that thing slides in and out. I mean, it's they use high quality parts in it. I'm sure they designed it to get the most out of it that they could. I imagine it's a pretty high queue. Hey, I saw, and I'm going to try this for the show one night. I saw there's construction to make these duplexers out of coffee cans. The guy has the center adjustable rod. He has the
is that decaf or caffeinated?
I don't know what it was. It was I don't know if it was 6 pound.
It depends on the power rating of your transmitter.
Oh,
I think I'm going to do that. I think I'm going to try it. It looked very simple to do, so we're gonna try that. This is exciting.
You're gonna try the decaf or the caffeinated?
I might try a paint can, latex versus enamel or something like it. I don't know.
Try Red Bull.
Yeah. So I don't know. I'm gonna try it there. All right.
Yes.
All right.
By the way, I do tune filters for the wireless ISP band, which are 2.4 gigahertz and 5 gigahertz, and those have about 8 cavities hooked up in series.
Oh,
so
wow! Really?
Yeah. So you have to go back and forth between the cavities. Sometimes you'll spend a couple of hours getting everything right. It can be quite a challenge. But the tricky thing is to get a good impedance match to your antenna. Yep. Because if the SWR, if you have SWR that's even 1 to 2, all of that energy bounces back through your filters and puts more stress on them, and they don't work as well.
And that stays as a common mode current, Brett?
It may not be that'll be a common mode current. Hopefully, if you have any anything coming back on the outside of the coax, you can ground that out.
Okay.
All right. Hey, before I jump into that, just let me do 2 more things here real quick, guys. Man, we got a lot to talk about. I want to tell you what's happened to W5KUB 113. I think we're not getting reports anymore. We set records with it. We've been flying now for 450 days. This is a 32-inch, basically a 32-inch party balloon with the homebrew tracker. And you guys have seen, you guys have seen the tracker we fly right there. The whole thing's 7.1 ounces, and it will talk 7,000 miles. And every 10 minutes we would get a report where this thing was. So what happened, I think the UV light has destroyed it, probably. It was getting where, we're supposed to get transmissions every 10 minutes. It was getting where our number of transmissions per day were being reduced. And then it was getting to be where they might go 2 days without hearing from it. And maybe the next time 3 days or 4 days without hearing from it. And it just started getting worse and worse and worse. So I think the UV got it. I think we're still flying. I think 113 is still flying. It'll be up around 480 days now. But we can only claim 450 days of flight because, that's the last report we got. but I can guarantee it's still flying. So it looks like we made about, I don't know, about 30 times around the world with this balloon. And of course, most of the flight, and this is very unusual, we started out in the northern hemisphere. Normally they will not cross the equator, but this one did. It crossed at Africa, went to the southern hemisphere, and flew down there for about 11 months. And then it came back up to the northern hemisphere, and it did another lap or two. So there's about 30 laps. You know, the circumference of the Earth is about 28,000 miles, meaning, you know, if you'd flown around the equator, we would have flown maybe 780,000 miles. But since we were flying at lower latitudes, I would imagine that we probably flew half that, maybe 400,000 miles. You know, so I don't know. We're gonna get another one in the air pretty soon. Nobody's been able to run one on a battery yet, just because the batteries will not operate at the temperatures up here at minus 40 Celsius or minus 40 Fahrenheit. I did have some special batteries built in China. I just got them in this week, and they claim they will work at minus 40. So we're gonna try to get something back in the air, and we're gonna see if we can't get 24-hour transmissions instead of just during daylight hours. So that's where we are, 113. Hate to see it, but I have faith it's still flying.
It did really good, though.
Yeah,
my gosh,
it did.
That's amazing.
It did. And 112 right before that, it flew 320 days and started acting the very same. We were starting to get reports every 3 or 4 days, and you know, it got further and further apart. So, but each time, you know, we wouldn't hear from it for a week, and then we'd get a single report. But each time, the altitude was still right up here at 49,000 feet every time. So, I think it's still flying. Okay, hey guys, we'll be right back, and we're going to get right into the duplexer tuning and playing with the spectrum analyzer here. So everybody just stand by a second. We'll be right back with you. Keep your competitive contesting edge with Icom. Icom's high-powered base stations cut through the pileups, letting you work the bands and record those contacts. Contest from the comfort of your home or remotely with the RS BA1 app. The IC7851 gives you a new window into the RF world and is HF excellence unparalleled. With faster processors, higher input gain, higher display resolution, and a cleaner signal. It is truly the pinnacle of HF perfection. It has dual receivers, digital IF filters, high-resolution spectrum waterfall. The IC7610 is a direct sampling, software-defined radio that has changed the world's definition of an SDR transceiver. Features include RF direct sampling, 110 dB RMDR, independent dual receivers. Create your own band opening with the IC9700. This transceiver brings direct sampling to the UHF VHF weak signal world. This all-mode transceiver is loaded with innovative features that are sure to keep you very busy. It has fast processors, higher input gain, higher display resolution, and a cleaner signal. Included are real-time high-speed spectrum scope and waterfall display, smooth satellite operation with 99 satellite channels, dual watch operation, and full duplex operation in satellite mode. The IC7300 is the high-performance innovative HF transceiver with a compact design, and it will far exceed your expectations. This innovative HF transceiver digitizes RF before various receiver stages, reducing inherent noise in different IF stages. The IC7300 changed the way entry-level HF is designed. Features include RF direct sampling, 15 discrete bandpass filters, a large 4.3-inch color touchscreen, real-time spectrum scope. For more information on Icom radios, visit www.icomamerica.com/amateur. All right, we're back, and hey, Jim just informed us he just committed a Glenn. I think he fell asleep during the Icom deal, so I don't know, man. All right, are you awake?
Sorry,
are you awake
guys.
now? That's all right. You awake now, Jim?
Some of the meds that I'm taking are really, really powerful.
Yeah.
I'm taking chelation things and other stuff, and what it's, I'm not allowed to drive anymore because I spontaneously fall asleep.
Yeah,
and I'm
that
usually
would be good.
pretty good during the daytime and then come for a second. My wife can be talking to me and I'll fall asleep, and
Oh, that's
the other
probably
night
not,
she couldn't wake me up.
yeah, yeah.
Couldn't get. I was in such a deep sleep, but the oncologist says that's okay.
Oh yeah.
Sleep is good.
Oh yeah, yeah.
So I think I'm going to beg off for tonight.
Okay.
I don't want to embarrass anybody.
All right. Well, we're going to get into some fun stuff here with the tuning of the duplexer next. You'll have to pull it up on YouTube and look at it.
I do want to see that. Yeah.
Yeah.
It's,
So we're going to jump right
yeah.
into it. If you need to go, just go. And hey, man, we're glad you're with us tonight. Stay as long as you can, and pull it up on YouTube.
Okay. Sounds good.
All right, man. All right. So let's get into the duplexer just real quick. So let me see if I can bring it up right now. And all I got to do is figure out what button to push here. Okay, here we go. Let me bring it up here. That looks pretty good. Oop, that didn't look good. Okay, here we go. Here we go, here we go. Here we go, right there. All right, let's walk over to the workbench. And this is the duplexer we're going to tune today. We're going to be tuning the band pass and the band reject on all four of these cavities here. This is a Motorola T1507. I looked it up on the internet here under the Repeater Builder website, T1500 model. And let's look at the specs real quick here. Let me pull it down here. You can see this is very extensive. It has all the information in here about it. This is the configuration that we're going to be, our final configuration with 4 cavities. Okay, and then let's see. Inside there's a couple of things we're tuning. These are some stubs that will actually be moving to tune the reject frequency. And let's see what else we got here. Here's some of the waveforms that we're going to be looking for right here, and the amount of attenuation that we get. And you'll see that on the spectrum analyzer here in a minute. Let's look at the specs real quick on this thing. If I can get there. Here we go. We're going to be doing the T1507 right here. If you look, it's a 5 meg wide split. Minimum, let's see, receiver isolation. We just talked about that. A minimum of about 55 dB. It covers the range. And we didn't have the equipment back then that we have today. For instance, to really do this right, we need a spectrum analyzer and tracking generator. Well, many of you probably have the Nano VNA. It will do the same thing, but this little thing is so complicated for me, I can't work it. So instead, today we're going to be using the Regal DSA 815 spectrum analyzer with the tracking generator. And we're going to set that up to tune these cavities. Now, we got 4 cavities here. 2 are for the receive side, 2 are for the transmit side. And the repeater split is a 5 meg difference in frequencies. So right now, what I'm going to show you is just we're going to tune the receive frequency cavities, and the tuning is the very same for the transmit cavities. So let's do this. Let's hook the generator up here. Well, first of all, we need to do the cavities individually, and then we'll connect them together, and then we'll kind of fine tune it. So I'm going to take off the connector here. And here, now since this cavity is a passive cavity, there's really no in and out to it. So I'm going to take the signal generator cable right here. We're going to go into the cavity here, and then the receive cable here off the spectrum analyzer. We'll put this in the other side of the cavity, right here, so I can reach down in here. It's kind of crowded. Okay, so we've got our signal generator going in one side, and we've got our spectrum analyzer on the other side. Let's set our spectrum analyzer up right here. So we know our frequency is going to be 462.55. So I'm going to put frequency in here of center frequency of 462.55, and it's megahertz. Let's do a start frequency of something below that. We'll say 450 megahertz, and we'll put our stop frequency of say 470 megahertz. So that's going to give us a look at the cavities from 450 to 470, and we're gonna see how the cavities tune. Let's turn the tracking generator on. So let's see, tracking generator's on, 0 dB. Okay. All right. So we're generating now, and you can see there's our 0 dB reference line. We're transmitting with our signal generator at 0 dB. There's our 0 dB line. That's the signal strength of the generator. You can see right there, it's almost out on the line. But we need to try to tune these cavities. So let's do this. Let's put the center frequency. We'll go marker, or let's see, marker. The frequency we want to pass on this one is 462.55. So I'm just going to key it in here. 462.55. Let's see. Let's see. Okay. We're going to key it in right here. 462.55. Well, 462.5. That's good enough right there, just for demonstrating this. All right, now, okay, we go marker and normal, 462, we need to go 462.55, that's good, 462.56. Let's turn our marker on here. Okay, so I've got this marker, this little one here is our marker for 462. It's set. See, I can move it back and forth. Right now I've got it on 462. I want to put it on about 5.5. 5.6 is good enough for now. You can see we're passing here. We're actually rejecting here. So let's do this. Let's turn the cavity here. We're going to adjust this cavity a little bit by just turning this right here. And we should be able to move that bump over to where that one is. So here we go. You can see it's moving over. You can see it's moving over. And here's our attenuation, or the loss of the duplexer now. Right now we're losing 7 dB through our duplexer. So let's keep coming. Look at there. We're bringing our cavity over to our frequency we want to pass right there. And the difference between what our generator is putting in and what our cavity is putting out is only about 1.48 dBm. Okay, so we've got that one kind of peaked. Now, 5 megs up at 467.55 is our receive frequency. So that's what we want to put here on a duplexer. So I'm going to move this frequency to 467. 467 like 5.5 there, 5.6. There's 467.56. So we've set that one properly. There's where we need our notch there, but our notch is down here. So to fix that, to move that notch, we've got to move this little tab that's inside here, just by lifting it and sliding it like this. It's kind of hard to do. So let's watch the meter up here now, and I'm going to slide this, and we're going to try to get that notch right on. We're going to try to get that notch right on the frequency. It's real touchy. All right, we're close there. What I'm going to have to do is this. I'm going to have to kind of bump it. I'm going to put me a nut driver over it. I'm going to just kind of tap it a little bit. I've got the thing kind of just a little tight, but I'm going to bump it now. If you'll watch here on the meter up here now, as I tap it, you'll see we're changing the frequency slightly. Look, see, we're off frequency. I'm trying to bring it down on frequency. All right, that looks pretty close. Oh, that looks pretty close right there. So, all right. So what we've got now is we've got this notch at 467.56. Let's go 5 megahertz up or down. We're going to go to 462.56. Right there. All right, so I'm going to turn the knob and try to peek out again just a little bit. I see we have an insertion loss of about a minus 0.1. I'll see if I can make it any smaller. Oh, there's 0.4. Mm, 0.5. Okay, that's probably as close as we'll get it. If you remember the specs on the manual said 2 dB, a minimum of 2 dB loss. So we're real close there. I'm going to go back, since I turned that, I'm going to go back real quick to our other frequency that's 5 megs higher, which is the 467. There we go. See, we moved a little there. So I'm going to readjust it. I'm going to readjust it a little bit. Trying to move it down. There it came down. Okay. All right. So it's kind of a back and forth deal. It's kind of a back and forth. Let's go back up to 467. 467. I mean 462. 5.6. Okay. Okay, that's pretty good. Let's look at the delta. Now this is delta pair. All right, this is going to show us in dB. If you'll notice now we've got a 1R up here for our marker. And on delta, I'm actually able to bring another marker down. You can see a little 1 coming down right there. And we're going to bring that down to here. And you can read the difference in the frequency right there. You can see 5 megahertz difference. There we go. And that cavity right now is giving us about 44 dB of isolation. Okay, now we've got that one done. Okay. All right, so that's tightened down. So what we're going to do is we're going to real quick, we're going to tune the other cavity just like we did that one. I'll put this back. I almost put it in the wrong place. So as mentioned, the cavities here are pretty critical. The length of these cables are actually very important, and they have to be the right length to make everything in here work right. All right, so we're gonna just do the same thing to the second cavity. Really quick here. We're gonna take our generator. We're gonna go in one side. That's a stiff piece. It's a little hard line is what it is. All right, we're gonna take our spectrum analyzer. You need to get those tight. If you're not tight, you'll have dB loss there. So, okay, there's our spectrum analyzer. We'll into our spectrum analyzer. All right, let's look at it again now. Okay, so this cavity is not tuned. Again, we want to pass 462. There's our pass right there. You can see. Let's see what our pass is on. Yeah, it's not good. I'm gonna put this marker down at 462. Right there, and we got to move this filter down to this frequency right here. So I'm going to turn the big knob here on the duplexer. Okay. Now, if we look at the scope up here as the analyzer, as we're turning it, you can see I'm bringing the frequency, the pass frequency over. It's coming over. It's coming over, over. I'm still turning it. So right about there, we're passing the most signal. And 0 is our reference, and we are at, let's see what we're at. Let's look at something here. Okay. All right. That looks good. Now let's go to our reject frequency, which is going to be the 467.56 right here. So our cavity is not tuned for reject here. So I'm going to move this little stub again right here. I'm going to move this little stud right here. And the best way I found is to snug it down and put something over it like this and just kind of tap it to move it. All right. Oh. All right. And if you look up there again, that little 1 is right on frequency. So I'm going to tap it and try to get that 1 right on the notch there. There we go. That looks like that looks like it. We're going to go back now. We're going to go back here and we're going to re-peak. We're going to re-peak this. Looks like we're pretty close. And then we're going to go back and look at our notch one last time on that one. Put our notch back on 167.556. And if you look here, we're at 5 megahertz split from here to here. And minus 45 isolation there. Let's look at the delta pair again. So let's see, delta pair. Oh, I was already on it here. Yeah, we got about a 45 dB isolation. Okay, now. Okay, so let's put the two cavities back together in series with each other. We're going to just put them back in line here. So this is the transmit side. These two are the transmit side, 462.55, and we're going to see how the two work now tied together, and see what kind of isolation we can get. Let me get this in here. You might think that's funny. That's the wrong way for the T connector to be in, but I've looked that up, and this is the proper way for that T connector to be installed on this duplexer. All right, let's do that. Let's hook the other one up right here. All right, you know, the other cavities are in line now. The receive pass cavities are in line. I've got a dummy load on here just so it'll be terminated right here. All right, let's look. Oh, look up here now what we've got here. Wow. Okay, so hey, here's our pass frequency here. And then here's our reject way down here. So right now we're showing almost 88, almost 90 dB of rejection. You know, each of the filters was showing about 45 earlier. So let's see if we can fine tune this a little bit. I want to be right on this frequency here, 467. Oh well, we want to pass the 462. 462. That's where we've been adjusting, 462.56. Okay. And we're showing about 3 dB, 3.7 dB of loss in the duplexer there. That's not great. And if we look here though, we're off here. If we move the frequency to our peak here, you can see this is coming down here. Now it's 2.99. But look at the frequency. We're down at 462, 266. So let's put this frequency back on 462, 566. Let's see if we can move this pass over. And I'm going to do that by just trying to fine tune the knobs here on the on the thing. That's not doing much. Oh, that one did. That one moved it over a little. Yeah, we're down to minus 290, so that's pretty good. Let me touch the other one up a little bit. I'm going to watch this number right here. I can't tell too much about the peak there, but I can watch that number. 277, 28. Okay, we're going to leave it right there. And still fine tuning, barely turning. We're going to leave it right there. Let's check this notch here again, right here. So let me take the frequency back down to the 467. 467. This is 467.56. See, we're off a little right there. I'm going to try to adjust those notches again. It gets really critical here. It don't take much movement. So I'm just going to tap those little things again. Let's see. I think it's coming down a little bit, maybe. I don't know. Let's see. Let's see if I can get the other one. There's two of them here. Wrong way. I think that's it right about in there. So, wow, look at that. And if you look right up here, our duplexers now are giving us about 95. Let's go to this. Let's go to dB right here. Let's see, between that marker delta. Gotta make a couple of adjustments here. Okay. Yeah. Right now we're seeing between our pass and our reject, and our reject is off a little bit. We're showing about 92 dB rejection. Let me see if I can get it a little bit better. It's getting touchy now. Oh, wrong way. Making it worse. Oh man, getting really worse here. Chopping that over a little bit. Try moving the other one a little bit. Nope. Somewhere in there. And oh, it's really touchy. Really touchy. All right, I'm gonna leave it 90 dB right now. I'm gonna touch the knobs up, the actual thing, just a little bit to see what happens here. We're so close, 94. We're at 94 dB. 94, well, 92, 93, 94. All right, and just quick tuning. That's about as quick as we can get it. But as you can see, our duplexer now, we're passing at our receive frequency, and we're notching out our transmit frequency down here. So we do the exact same thing. We do the exact same thing here. We do the exact same thing here with the other two cavities, except we reverse the two frequencies. It's going to look just like this. You're going to have a pass and you're going to have a notch. And so again, we'll adjust the knobs. we'll adjust the little tabs right here that will slide in and out and adjust these two.
Go.
Okay, so you can see how handy a spectrum analyzer with a tracking generator is for tuning cavities and things. And that brings to mind, you know, a lot of people might want to just cut a quarter wave open, you know, for a filter. So let's test one real quick. So I'm going to take the spectrum analyzer here. Look, I've got just a piece of coax here. It's open on the end. Let's make this a filter. So look, let's go over here real quick to the computer here. I want to look at a couple of things. Oh, this is interesting here. Well, let's see if I can get it where you can see it better. Okay, you can see right here you can see the T adapter right there, and you can see coax to the antenna and coax, say, to a receiver, and this is the stud right here that we're going to be cutting here. It's quarter wave length open end. So let's see if we can do that for, oh, and look, another thing you got to do, this distance right here has to go to the center. The distance here has to go to the center of this connector. It can't go just to the end of the coax. A lot of people say when you cut this coax, measure to the end of the connector. Well, if you use a T, you're going to have to go up to the center of the T because that becomes part of the length of it. All right, so let's do this. I don't know what frequency. I have no idea what frequency this is on. Well, let's do something. Let's do a quarter wave matching stub right here. And this website's pretty neat. You know, let's put a frequency in here, say 100 megahertz. 100 megahertz. We know the velocity factor on this cable is 0.66. See, I need to clear all this. Let me see. How do I clear this? Well, let's see what happens. Okay, so I put a frequency in of 100 megahertz right here. Velocity factor 0.66. All right, so we had a wrong number in here. So we're going to set our frequency at 100 megahertz right here. We did a calculate, and it says our length of our quarter wave stub should be 0.495. Now, this is European. They use commas for periods. I learned in my job over the years. So 0.495 meters. Let's put 0.495 in here. 0.495, and that should give us 19.48 inches. 19.48. I'm gonna write that down right here. 19.48. All right. 19.48 inches to the center should give us 100 megahertz filter. So I'm gonna short it out. Let's measure 19.48 very quickly from the center. From the center of that T, 19.48. Oop. 19. All right, about there. 19.5 right there. All right. So I've got 19.5. I bet you it's not going to be 100 megahertz. I bet you it's not. Notice our end is open. And again, we're using RG58 coax. You get a much better filter if you use something like RG213 or LMR400. Okay, so we cut this at 19.48 inches long. It's open on the end. And our calculation says that should be a filter for 100 megahertz. Let's put it on the spectrum analyzer and see how many bet it's going to be on 100 megahertz. How many think it's going to be there? Well, we're going to find out. I don't think it's going to be there. I think it may be higher. I think it may be, I don't know. I'm guessing 110. I'm guessing 110 megahertz is where the filter is going to be. So what we're doing here, we're just putting this T in. we're putting this T in right here. So we're coming out of the tracking generator. We're going through the T. We're going back to our spectrum analyzer. On the T here, we have our 19.48 inch open quarter wave stub. Let's see what the spectrum analyzer says it is. I'm going to set the, let's see what I'm going to set. I'm going to set the start frequency. We're going to scan this. I'm going to set the start frequency about 50 megahertz. 50, and I'm going to put the stop at say 150 megahertz. I see a dip. But let's see, is that going to be 100? I don't know. I'm going to turn the marker on, and we're going to bring the marker down to that point, and we're going to see. I'm bringing that marker down, and as you notice, it's changed the frequency here. Ooh, look, we're at 117, 115. Bring it down. 113. It looks like when we cut that quarter wave opening the stud, it is at 112 megahertz. All right. So look, we wanted 100 meg. We wanted it to reject a 100 meg signal. So let's do this. Let's trim a little more off and see if we can bring it down to 100. So I'm going to cut off about a quarter of an inch. All right. I cut off a quarter inch. Uh-oh. You know what? I took it the wrong way. I should have made it longer. I knew that. Now we're filtering at 114. Okay, let's just say we wanted to filter at 120. We wanted a 120 megahertz filter. Let's just cut it off till we get to 120. Tell you what to do. I'm going to put this at 120 right here. See the frequency? I'm going to go up to 120 right there. All right, see where the 1 is right there? So our notch is below that. So I'm going to just keep trimming off. I'm going to keep trimming off until I get up to where that 1 is, right in the notch there. So here we go. There's an 1/8 of an inch. Ooh, didn't take much off. There's another 1/8. Did it take any off? I couldn't tell. I'm going to take a 1/2 inch off. Oh, look, a 1/2 inch is getting closer. I'll take a 1/4 inch off again. I'm going to take another 1/4 inch off. Look at there. Now our filter is at 120. So you can see it's not here. Now the interesting thing is it's only about a 23 dB notch. So that's not a whole lot, but it might help if you've got interference coming in from an antenna. You could put a stud on there and you could easily get maybe 20 dB of isolation on that signal. Now, what you could do is go 1/4 wavelength more this way and put another T here, and you could put another quarter wave stub right here, and you could probably double that, so you'd get about 40 dB. But anyway, that's kind of our experiments on cavities, duplexers, quarter wave open stubs. So hope you enjoyed it. All right, guys. I don't know why I kept saying studs. I knew it wasn't stud, but that's the word that was coming out. Hope you enjoyed that. I was just a quick tune of the duplexer. I'm gonna have to touch it up and go through it again. I just wanted to play with the spectrum analyzer and show you how much fun we had with it. All right. Looks like Glenn's still awake and Brett's still awake.
Yeah, that was actually kind of interesting. I'm still curious about why the T connector is done that way. I mean, I can't think of any electrical reason why it would have to be that way.
Well, let me see. Let me get a T here. Let me get the T if I can find it. There's one. And let's see, because you've got to measure to the very center there. You can't just measure the coax cable. So let's just see if there's a difference. I'm going to try to go from here to that end. Looks like about 3/4. Ah, well, hey, I can tell you why. I can tell you why. From the T up, it's about 1 inch to the center conductor. Going this way, it's about 3/4 of an inch.
Yeah, but can't you just tune a little differently and get it?
Well, I don't know. You know, as I mentioned, those cable links were all cut specific lengths.
Yeah, I mean, I would think that you should be able to.
I would think
tweak
it
and
would.
adjust.
I think that would optimize things to do it the way they say. But
Because not all T connectors are that way
Yeah.
either.
you know, I could probably put this T on there, and I'll do that this week when I
Because I was
tune
going to
in
say, I
again.
can probably grab a T that's equidistant on all three.
Yeah. So I'm gonna check it again. It probably wouldn't make a hill of beans difference. You know.
That's my thinking. Yeah,
Yeah.
but I was just curious about
Yeah.
that because I actually Googled it while you were going and I didn't find any
Yeah.
relevant hits.
Yep. All right. Let's see.
They're going to tune to. And so they can't really size the cable exactly anyway.
Have no idea of the Q.
Yeah, but I mean, overall, that was cool. I'm jealous of your tracking generator. I don't know if my spectrum analyzer has that.
You know, I had a really good spectrum analyzer here. The unit new was about $27,000. It finally went bad, and it would probably have cost thousands of dollars just to fix it. So I just bought me the Rigo. That Rigo's about, it's decently priced. It's right at I think it's about 1,000. I do have a Hewlett Packard spectrum analyzer over there. It does not have a tracking generator in it, but it's good to see things like, you know, power levels and things like that. It doesn't have the tracking generator. The tracking generator is just really neat. It from 0 to 1 gig, it tracks perfectly, you know, the entire distance, and you can see where is it, you know, at any time. So
Yeah,
it's
you're
really-
going to make
really
me go
cool.
dig mine out of the closet and see. I picked mine up at the auction of the old ITT
Oh,
electronics
yeah.
places. I mean, it was a nice looking analyzer, but I don't know if it's got the tracking generator or not.
well, it may have it. That's good to have. It's really good
I'll
to have,
whip
yeah.
that thing out in the morning and take a look.
Yeah. Okay. All right. Hey, guys, you've been listening to Amateur Radio Roundtable. If you're on shortwave on WBCQ, our show is live. Our video show is live on Tuesdays at 8:00 p.m. Central Time on W5KUB.com. If you're listening out there on shortwave, you're listening on Thursday afternoons, and we really appreciate you joining us here. Hey, be sure and click the subscribe button, if you will, to our channel here. It helps us out a whole lot. And hit the like button if you like it, and you know, the notify button. All that helps us to spread the word. We really appreciate you doing that. Join our Facebook group. 14,000 strong members in our Facebook group. Just go to W5KUB. It's not a personal Facebook group. It's the Ham Radio Facebook group. So just search for W5KUB and you'll be there. And don't forget, you can listen to us on any podcast carrier out there, iTunes, iHeartRadio, any of them out there. All right. Well, hey, that's about all I've got for tonight. We've run out of time, Glenn. What do you think, man?
Hey, I stayed awake. I'm good.
Think it's time for popcorn?
Oh, absolutely. Yes.
All right, guys. Well, hey, we'll see you all next week. Thanks for joining us, and hey, have a safe week, and we'll see you later. And let's see, what have I got to here? Let's see.
Well, try to stay warm, Brett.
Yeah, well, let's see what I got.
Well, I'm going to be in my ski bibs tomorrow, going out there, finish the microwave work. It's going to be.
Yeah. Okay. All right.
Just
Good
keep
night.
that weather there. We don't want it over here.
All right. Good night, everybody. Good night.
Good night.
So you're saying I can ask this cat any question?
The cat is connected to the computer. You just type in the question, it will read his mind. There the answer comes.
You're the man! I've been looking for this for weeks.
So now you
All
have a
right.
new do that with.
Do what?
Now you have a new cat to do that with.
Yeah.
Yeah.
Oh, he's a mess. He didn't come up